Okay, so if our rate of change of p with respect to t is proportional to p times L minus p, we can draw plenty of conclusions, but let's first look at this expression p times L minus p. Okay, well, clearly if p is 0, p times L minus p versus p will have the graph of p. The graph of this versus this will have a point here, right? And then clearly if p equals L, we're going to have a point here. So here p equals L. And then I think we asked to graph this from 0 to 2L. So if 2L is here, then what's the coordinate of this point? Well, if p equals 2L, then this is going to be L minus 2L is going to be negative L times 2L is going to be negative 2L squared, right? Okay, so we're going to come down to something like negative 2L squared here. We don't know exactly where that's going to be because we don't yet have a relative scale here. But let's just put it here. Okay? So now we do have a scale. This is negative 2L squared, right? So the graph then has to go through this point, and this point. And the other thing we can see is this is a quadratic function of p. Okay, so p times L minus p is negative p squared plus pl, right? Now, if we understand quadratic functions, this is quadratic function.
Just out of curiosity, shouldn't those be shouldn't that be p and 2p instead of l's? Because you have from 0 to p to 2p in the problem.
About 2L.
Oh, okay.
Okay. So type of my error, that change that to a 2L, and I'll do that on the document. Okay.
Okay.
Because
Well, I thought when I used p,
2p on the p-axis
Yeah,
doesn't have any meaning.
yeah, I didn't understand why I was
Yeah.
getting nothing.
So
I was getting a little confused. So it's supposed to be L to 2L. Okay.
Okay, that's a parabola opening downward, right?
Right.
The axis of symmetry is this coefficient of p, right? Negative this coefficient of p divided by the coefficient of p squared. Okay? Well, just using what we know about quadratics, and you might have to think that through a little bit. The axis of symmetry is p equals L over 2. So we have a parabola through these points, and the axis of symmetry is here. Now, of course, we know from the symmetry of a parabola that if it goes through these 2 points, the axis of symmetry has to be halfway between, right? But we want to pull out all the characteristics of a quadratic in doing this. So we have to draw a parabola through these points that hits this. It means it's going to have to be, well, let's try it this way. Board's being a little stubborn here. Okay? So it's going to look something like this with its vertex here. Right? And the vertex occurs at p equals L over 2. Okay? So the y-coordinate of the vertex, with p equals L over 2, then L minus p is L over 2. Multiply that by L over 2, you get L squared over 4. So we have L squared over 4 here. Now, in sketching this, of course, we're just talking about curve sketching, but it's good to be able to do a reasonable curve sketch. Does this scale here appear to match this scale here? Well, if this is 1/4 of L, then L's about this big, right? And 2 of those makes this, sort of. So it looks like when I sketched this attempt at a parabola, I didn't do too badly. Now, if you actually measure these out, you find this is probably more like 1/6 or 1/7 of this than 1/8, right? But 1/4 of L squared should be about 1/8 of 2L squared, right? So, we try to check everything for consistency. This isn't a specific differential equation skill, but the whole idea of getting the picture accurate is something we want to apply to everything we do, okay? Especially if you're going to be an engineer. You want to get the best picture you can. Okay, now, so we've spent a fair amount of time just graphing this function, okay? When we're really after a graph of P versus T. Okay, now there are different ways to deduce this graph. We could also do a direction field. We're going to do that, okay? And then ultimately we'll do the arithmetic and solve the equation. All we have to do is separate things into partial fractions, and you'll see how that works, okay? But let's think about now how this graph is related to this graph.